Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Derive another formula for the area of a cyclic quadrilateral defined by area of cyclic quadrilateral square root of quantity s minus a, s minus b, s minus c times s minus d, where s is half the perimeter and a, b, c, and d are the sides. Also compute the area of the cyclic quadrilateral from Vitamath 38 to 40 problem, and we'll apply this formula. So the cyclic quadrilateral should be drawn. And let's divide it by two diagonals, diagonal AC, which is diagonal 1, and diagonal BD, which is diagonal 2. Now, in terms of area of triangles, the area of cyclic quadrilateral is equal to area of triangle ABD plus area of triangle BCD. And remember that opposite sides of triangles are supplementary. So if the angle here is angle A, then angle C is 180 degrees minus A. Angle B is angle B, and angle D is 180 degrees minus angle B. And remember that their signs are equal for supplementary opposite angles. So area of cyclic quadrilateral is 1/2. Sine A is common, sine A over 2. Then we have product of adjacent sides AD plus BC. So that's the area of cyclic quadrilateral. 1/2 of quantity AD plus BC, sine of angle A. Also, in terms of angle B, it is 1/2 sine of angle B times quantity AB plus CD. So area of cyclic quadrilateral is also 1/2 of quantity AB plus CD sine of angle B. So having known that, then we have to apply cosine law for triangle ABD for diagonal 2. Diagonal 2 square equals a square plus d square minus 2 times AD cosine of angle A. Remember cosine law. Then in triangle BCD, diagonal 2 square equals b square plus c square minus 2 times bc cosine of angle C, which is 180 degrees minus angle A. And take note that from trigonometry, the expansion of cosine of 180 minus A is cosine 180 cosine of A plus sine 180 sine of A. Sine 180 is 0, so 0 times sine A, 0. So don't mind the second term of the expansion of cosine 180 degrees minus A. We are interested of the first term, which is cosine 180 cosine A. So cosine A, of course, is cosine A. Cosine 180 is negative 1. Therefore, cosine of 180 degrees minus A is negative cosine of A. So negative cosine of A times negative 2bc, this becomes 2b positive 2bc cosine of A. So diagonal 2 square is equal to, so that's the expansion of cosine 180 minus A, negative cosine of A. So this equation becomes diagonal 2 square equals b square plus c square plus 2bc cosine of A. So equating here for diagonal 2 square, so we have a square plus d square minus 2ad cosine angle A is equal to b square plus c square plus 2bc cosine of angle A. So factor out cosine of angle A and 2 and put b squared and c squared to the left of the equation. So we have 2 times cosine angle A times quantity AD plus BC equals a squared minus c squared plus d square minus b square. So I hope that you can follow this simplification. So cosine of angle A therefore is quantity a square minus c square plus d square minus b square all over 2 quantity AD plus BC. Then going back to area of cyclic quadrilateral from here. So area 2 times area, so because this is 1/2, 2 times area of cyclic quadrilateral is equal to AD plus BC sine of angle A. So squaring, so for area of cyclic quadrilateral square equals quantity AD plus BC square sine square of angle A. And take note that by trigonometric identities, sine square of A is 1 minus cosine square of A. So for area of cyclic quadrilateral square is quantity AD plus BC square 1 minus cosine square of A. So let us obtain the value of 1 minus cosine square A because cosine A is here. If we square it, then we just square the numerator and the denominator. So 1 minus cosine square of A is equal to 1 minus, then we square this because this is cosine of A. Quantity A square minus C square plus D square minus B square, close square, all over the square of the denominator is 4. Quantity AD plus BC quantity square. So that's the value of 1 minus cosine square of A. So we then substitute into this equation here. So 1 minus cosine square of A is equal to quantity 4 quantity AD plus BC square minus quantity A square minus C square plus D square minus B square closed square all over 4 quantity AD plus BC square. So substitute this value of 1 minus cosine square of A into this equation here. So 4 area of cyclic quadrilateral square equals AD plus BC quantity square times, let's copy this expression. Then we can cancel the factor AD plus BC quantity square here. So canceling out AD plus BC quantity square. And then 4 times 4 becomes 16 area of cyclic quadrilateral square, then equals 4 quantity AD plus BC square minus quantity A square minus C square plus D square minus B square quantity square. That's the simplification. And take note that 4 times quantity AD plus BC square, only AD plus BC is squared. This is difference of two squares, and we note that we can write this as 2 quantity AD plus BC, then quantity square. So this is a perfect square. This is also square, so difference of two squares. And remember the factored form of difference of two squares, x square minus y square, would be x minus y times x plus y. So x square minus y square is x minus y quantity times x plus y, where x is 2 quantity AD plus BC and y is the whole of these terms inside this parenthesis. So 16 area of cyclic quadrilateral square is equal to 2 quantity AD plus BC minus quantity, so we just copy this. Then the other factor is 2 quantity AD plus BC, then plus, then we copy the terms inside this parenthesis. So that is x minus y times x plus y. Expanding, 16 area of cyclic quadrilateral square equals 2AD plus 2BC minus A square plus C square minus D square plus B square, then times quantity 2AD plus 2BC plus A square minus C square plus D square minus B square. Rearranging and noting that we have perfect square trinomials here. So B square plus 2bc plus c square as one group, then minus, so 16 area of cyclic quadrilateral square equals quantity b square plus 2bc plus c square minus quantity a square minus 2ad plus d square, close. Then for the second factor, here, we first write a square plus 2ad plus d square, then minus group the following, b square minus 2bc plus c square. So let's check that we have positive b square, then 2bc, which is this, plus positive c square, then minus quantity a square, so that we have negative a square, then minus 2ad, so that negative of negative 2ad is positive 2ad, which is this, then plus d square, so that negative of d square is negative d square, which is this, so it's correct. Then a square, which is a square here, plus 2ad, which is this, then plus d square, which is that, minus quantity b square minus 2bc plus c square, so that we have negative b square. Negative of negative 2bc is positive 2bc, which is this, and negative of c square is negative c square, so that's correct. Take note that these first three terms of the first factor are perfect square trinomials. We can write that as b plus c quantity square. This is also perfect square trinomial. We can write this as a minus d quantity square. So 16 area of cyclic quadrilateral square equals quantity b plus c square minus a minus d quantity square, then quantity a plus d square minus quantity b minus c quantity square, which forms another, the first factor we have difference of two squares, the second factor is also difference of two squares. So let's go back to this way of factoring difference of two squares. 16 area of cyclic quadrilateral square equals quantity b plus c minus quantity a minus d, then quantity b plus c plus quantity a minus d, then quantity a plus d minus quantity b minus c, then quantity a plus d plus quantity b minus c. So that's the way of factoring difference of two squares. So simplifying, we have 16 area of cyclic quadrilateral square is equal to quantity b plus c minus a plus d, or b plus c plus d minus a, then a plus b plus c minus d, quantity a plus d plus c minus b, this one, the third factor. Then simplifying the last, a plus d plus b minus c. So let's have that. Let's copy this on the next slide. So from the preceding slide, 16 area of cyclic quadrilateral square is b plus c plus d minus a times quantity a plus b plus c minus d times quantity a plus d plus c minus b times a plus d plus b minus c. So we add a here, then subtract a also. So this first factor becomes, so 16 area of cyclic quadrilateral square is quantity a plus b plus c plus d minus 2a, then this one, a plus b plus c plus d minus 2b, then this one we add c, subtract c, so a plus b plus c plus d minus 2c, then finally this one, add d, then subtract d, a plus b plus c plus d minus 2d. We note that 2s is the perimeter, 2 times s, because s is half the perimeter, so a plus b plus c plus d. So we simply replace a plus b plus c plus d here by 2s. So 16 area of cyclic quadrilateral square equals 2s minus 2a times quantity 2s minus 2b times quantity 2s minus 2c then times quantity 2s minus 2d. Factor out 2 to each of these terms in each parenthesis which is common. So 16 area of cyclic quadrilateral square is 2 to the 4th times quantity s minus a times s minus b times s minus c times s minus d. And 2 to the 4th is also 16, so we can cancel them. Then extract the square root. So what remains here is area of cyclic quadrilateral, which is square root of s minus a times s minus b times s minus c times s minus d. So this is the formula that is required. We want to achieve, and we have done it. And I hope that you can easily recall it. This is the Heron's formula for triangle, but this is the area of cyclic quadrilateral. So from Vitamath 38 to 40, which we solve also by other methods, but it was only sides A and B that were given and the radius or the diameter of the circumscribing circle. Thereby, in the preceding problems, we solved C to be 42.81 units and D 44.6. So A is 30, B is 18, C is 42.81, and D is 44.6. 2S therefore is 30 plus 18 plus 42.81 plus 44.6 divided by 2. So S is 67.705 units. So 67.705 units minus 30. So S minus A is 37.705. S minus B. So 67.705 minus 18, 49.705. S minus C, 67.705 minus 42.81 is 24.895 units. And S minus D, 67.705 minus 44.6 is 23.105. Substitute into this formula, then area of cyclic quadrilateral is square root of 37.705 times 49.705 times 24.895 times 23.105. Using your calculator there, area of cyclic quadrilateral is also 1038 square units, which is the same area computed in Vitamath 38, 39, and in problem Vitamath 40. So that means that this is correct. So I hope that you have gained your additional knowledge on cyclic quadrilateral, especially for the area. And I hope you can recall it and you can derive the formula by your own.